level as students. I was meant to take some days off of revising, but I just couldn't leave the maths out. We have about 10 days to exams now, and so I am going to go through all of calculus because I'd say it's most people's hardest part. Um, and we're going to start with the most basics of the basics, and we're going to work our way up. It's going to be a multi-part video, so it's not going to be all in one. If you feel like the basics of your calculus are fine, then maybe start with part two. But if there's some gaps in your knowledge, I'd recommend just watching this anyway. It's going to be a quick walkthrough of differentiation, and that's going to cover quite a lot. So that's going to be product rule, chain rule, quotient rule, trig functions, parametric differentiation, implicit differentiation, higher order derivatives, rates of change. We're going to get through it. Then in part two, we're going to cover integration, and then we're going to do differential equations, and then we're going to look at some of the harder examples. We're going to look at some, tricky bits and bobs, and we're going to get through it. But let's begin with differentiation. Okay, so a standard polynomial function. Let's make one. Let's do it now. Actually, let's write differentiation. Differentiation. Okay. Nice. Number one. Let's go. Let's say y equals 5x to the 4 minus 3x squared plus 7x minus 1. To differentiate this, there is a formula. And I always use, by the way, you're going to hear the entire video, y prime. It is the same as dy by dx. It's just shorter to write. This is longer to write than this. So I don't understand why people write dy by dx. It's the same thing. It's allowed. Just say y prime. Okay, equals. So the formula is if we have x to the n, it's going to become nx n to the minus 1. So pretty simple. Let's start with our first function here, 5x to the 4. Well, we're going to bring down the power. We're going to get 20x. Take one away from the power. 20x cubed minus 6x plus 7. Simple, right? Let's do another one. Let's go for y equals 2x to the 5 plus 4 over x. Okay. First things first, let's rewrite our indices. So we're going to have 2x to the 5 plus 4x to the minus 1. So y prime is going to be, well, 10x to the 4th plus minus times through by the minus. We're going to get a minus 4x to the minus 2, which you can rewrite in the form they had it in before as minus 4 over x squared. Nice. Let's do some fractional indices. So we could have y equals 7x to the 3 over 2 plus, no, let's go minus. 5x to the minus 2. Okay. So times through, 7 times 3 is 21. So we're going to have 21 over 2 x to the half. Minus and a minus make a plus. So you're going to have plus 10x to the minus 2 minus 1 is minus 3. Or, like I said, you can have this as 10 over x cubed. Cool. I'm going to give you an example. Oh, wait, we should probably cover the square root as well. So let's do y equals the square root of x plus 3x to the 6. Rewrite this as a power, x to the half plus 3x to the 6. Y prime is going to be a half x to the minus a half plus 18x to the 5. So let me give you an example now. Let's do these. Let's go number one. Let's go for y equals 5 over x cubed plus 2x to the 7. And let's go for number 2. Y equals x plus 1 all squared. So if you can, try these examples. It should be nice and simple. Pause and have a go. I'm going to walk through it now. You can rewrite this as a power. So this is going to be y equals 5x to the minus 3. So let's go 5x to the minus 3 plus 2x to the 7. And then just do your power rule. So this is going to be minus 15x to the minus 4. plus 14x to the 6. This one, expand your brackets out. You're going to get x squared plus 2x plus 1. Power all through. You're going to have y prime is going to be equal to 2x plus 2. Nice and simple. So that's going to be your standard power rule. It should come nice and simply. What we're going to do next is we're going to do some trig integrals. Now, we're just going to start with the basics, just sine and cos, and we're going to write out our little table. So let's go for y equals sine x. Y prime becomes cos x. Now let's differentiate that. Sorry, not y prime. Let's go y equals cos x. The derivative is going to become y prime equals minus sine x. Let's go for that. Y equals minus sine x. Y prime is going to become minus cos x. And now if you differentiate that, you're going to get back to the start. Y equals minus cos x. Y prime equals sine x. Okay? Nice and simple how to get around. And so that's the basics. You just have to learn this. Sort of like a little clock that goes around. You will be needing this quite a lot. And let's do some questions on this. We're only going to do a couple, and you just have to be careful of what's going to happen to the pluses and the minuses. So let's go for number one. You can try these, and I will go through them. Let's go y equals 7 sine x. Number two, let's go for y equals 4 cos x. Number three, let's go y equals 3 sine x minus 5 cos x. Number four, we're going to do 5 of these. Let's do y equals x squared plus sine x. And then number 5, let's go for sine x plus cos x plus 5x squared. Pause and have a go, and let's go through them. Okay, so number one, we've said the derivative of sine is cos, so this simply becomes y prime equals 7 cos x. Number two, did you catch on? The derivative of cos x is minus sine x, so we're going to have a minus in front of our 4, so we're going to have minus 4 cos x. Number two, y prime is going to be, well, sine x is cos x, so we're going to have 3 cos x. We have a minus, but the derivative of cosine x is minus sine x. So we have minus 5 minus, so a minus and a minus make a plus, so we're going to have plus 5 sine x there. Here, we're using what we've just learned. The derivative of x squared is going to become 2x plus minus cos x. Sorry, that should be a plus. I was right. Derivative of sine is cos. And now, lastly, let's do this one. Y prime, well, derivative of sine is cos, so cos x. Derivative of cos is minus sine x plus 10x to the power 1. So just 10x. I also forgot to explain why when we have something like just 7x, it goes away. So if we have the function y equals 7x and we want to find y prime of x, well, look at your powers and apply the power rule. We said it's x to the n becomes n x to the n minus 1. So if we have 7x, we're going to do 7x to the 1 times through by 1. You're going to have 7x to the 1. Take away 1 to the minus 1. So 7x to the 0. And anything to the power of 0 is just going to be 1. So we just have 7 lots of 1, which is just 7. So whenever you see the derivative y equals something x with no power, it's just going to be whatever's in front of it, the coefficient, which is just going to be 7. And similarly, when you have y equals 7, we don't have a power of x, so it's just going to go away. Cool. And that's really helpful at reducing higher order derivatives, basically. Anyway, let's move on next, and let's do some exponentials and logarithms. It's pretty simple. Y equals e to the x. Its antiderivative stays the same. So when you differentiate e to the x, you're just going to get e to the x. And the reason for this is because a special property of the number e. So for any exponential function where we have, I'm going to have to use the other notation now, d dx of a to the x, it's going to be a to the x ln of a. So if the base is e, it's going to be e to the x ln of e, right? And since ln of e is just 1, you're just going to get e to the x times 1, which is just e to the x. So e is the unique number whose exponential equals its own derivative. And you can even show like the contrast. If we had 2 to the x, y equals 2 to the x, and we apply our formula, it's not going to be 2 to the x. Y prime, like I've just said, there's this formula here, a to the x ln a. So it's going to be 2 to the x ln 2. That's your formula. Similarly, if we look at 10, y equals 10 to the x, our derivative is going to be 10 to the x ln 10. But the derivative of e to the x is always e to the x because e is our base and ln of e is 1. So nice and simply, the derivative of e to the x is just e to the x. But let's do some more questions because you can do some slight variations. And obviously we have our ln function that we need to learn how to differentiate as well. So let's go for number 1, y equals e to the x. Let's go number 2, y equals 5e to the x. Number 3, let's go e to the 2x, y equals e to the 2x. And then let's do a ln one, let's do y equals ln x. And then number 5, let's go for let's do something unique. Let's see who can do this. Let's do this. There's your 5 questions. Have a go. Pause and try, and I shall begin to give some answers. Okay. So, this is going to be y prime equals e to the x. This is going to be y prime equals 5e to the x. Should be able to get these. Now, what do you do here? You actually have to use the chain rule. And so you're going to bring the power down, and you're going to get 2e to the 2x. So y prime is going to be 2e to the 2x. And then this one, the derivative of ln x is 1 over x. So y prime is going to be 1 over x. Again, that's just something you have to learn. And who could do this one? Well, you have to use the product rule, which we haven't learned about yet. But you have the derivative of x and e to the x. It's x is a product of e to the x. And so you have to apply the formula uv prime plus vu prime. And so the answer is actually, if anyone could do it, e to the x lots of x plus 1. But we will go through that when we come across the product rule. So now that you know that the derivative of ln x is 1 over x, you also know that the integral of 1 over x is going to be ln x. But a lot of, again, so similarly, so many people say, why is the derivative of ln x 1 over x? And that also has an explanation. So since if we take y equals ln x, let's go through this because I don't know if many teachers have actually taught this. Let's go y equals ln x. Well, what this means is x equals e to the y, right? If you wanted to get rid of the ln, you'd exponentiate both sides. So x equals e to the y. So now differentiate both sides with respect to x. Let's have the derivative of x and e to the y. Well, the right, for the left side, we're just going to get 1. But for the right side, it needs the chain rule because y depends on x. So e to the y dy by dx, um, 1 equals this. And if you want to solve for dy by dx, you're going to have 1 over e to the y equals dy by dx. And now we know that x equals e to the y, because that's what we got here. X equals e to the y. So your answer is going to be 1 over x equals dy by dx. So there you go. The derivative of ln x is 1 over x. Nice and simple. It's a cool little explanation for where that comes from. So now we can move on. We've covered exponentials and logarithms. Hopefully you've got all of this. This is some pretty intrinsic stuff. Obviously, if you didn't understand the explanations for e to the x and ln x, that's okay because I don't know how talked about they are. But now we're going to do the chain rule. I can't remember the formula for the chain rule, but you should be able to just understand it in practice. I'm sure I could come up with it. I just have to use f and g, and I don't like writing f and g out. Let's just have a look at an example. Let's go number 1. Y equals 3x plus 2 to the 5. What you do is you're going to differentiate like you would treating this as a function. Like if we said 3x plus 2 equals z, we have z to the 5. You're going to do the power rule. So nzn minus 1, and that's going to be 5z to the 4. But now you're going to times by whatever the derivative of the inside is. So times z prime. Okay? Which is going to be 3. Because 3x plus 2 differentiates 3. So it's going to be 3, so you're going to have 15 lots of z to the 4. And then whatever the inside is, sub it back in. 15 lots of 3x plus 2 to the power of 4. That's how you do the chain rule. You won't actually use the Z notation, so don't actually worry about that. But just that's my way of explaining it. I think it's commonly written with some function f of x and g of x, but the explanation is it's just the derivative of the outside of the bracket times the derivative of the inside of the bracket. So treat it like some function and then differentiate it and then times by whatever the derivative of the function is. It's probably not the mathematically correct way to explain it, but who cares as long as you can do the question. Let's go. X squared plus 1 to the 7. Let's walk through this one as well. Bring the power down like you would. 7 lots of x squared plus 1. Take 1 away. 6 times by whatever the derivative of this is. Well, x squared plus 1, let's go y equals y prime is going to be 2x. So now times through by 2x. You're going to get 14x lots of x squared plus 1 to the power of 6. And so that's how you're going to do that function there. Let's go for a big square root. It's always nice. Let's go y equals the square root of 5x minus 1. Y equals, rewrite it, 5x minus 1 to the power of half. You have an x inside, so it's not dependent. And we're going to differentiate. Y prime equals, bring the power down, a half lots of 5x minus 1 to the power, take 1 away, minus a half, times by the derivative of the inside, which is going to be 5. So you're going to have 5 over 2, lots of 5x minus 1 to the minus a half is y prime. Cool. See if you can do some questions now if I bring it up. Let's go. Number 1. Sine to the 4x. Sine of 4x, sorry. Let's go. Sorry, that should say y equals. Y equals. Number 2. Y equals cos of x squared. Let's go for y equals e to the 3x squared. And let's go for y equals ln of 2x plus 7. Slightly trickier now. We're getting into the slightly harder bits. Give it a go. And let's see if you can do it. Hopefully we're going to get them. let's go. Number one. So the derivative of sine x is cos x. So you're going to have cos 4x. What's the derivative of 4x? It's going to be 4. So we're going to have 4 cos of 4x. Next up, derivative of cos is going to be minus sine. What's the derivative of x squared? 2x. So you're going to have minus 2x sine x of x squared. Nice and simple. I think. Yeah. Number two, you're going to be doing e to 3x squared. So we're going to have the derivative um, down here, bringing the power down, is going to be 6x. And so we're going to get 6x to the power e 3x squared. And then lastly, the derivative of ln is going to be 1 over x. And then the derivative to the inside is just going to be 2. So we're going to have 2 over x is our function, 2x plus 7. Nice. Cool. All right, so we got the chain rule done. What's next? I think product rule or quotient rule. I should probably do product rule first. I think most students prefer it, and it's the easier one. Let's go for product rule. So, there is a formula, a nice, beautiful little formula. We're going to do it in U and V notation. Again, I don't do F's, I don't do G's. And it's going to be Y equals UV, Y prime equals VU prime plus UV prime. Nice and simply, what does this mean? Best way to do it is with an example. Let's go for x squared, 3x squared. Pick one to be u, pick one to be v. Let's go u, let's go v. And now write it out. What's v prime? 6x. Sorry, what's v? 3x squared. What's u prime? 2x. Plus, what's u? X squared. What's v prime? 3x squared. Differentiate, 6x. Times through everything, so we're going to get a 6 and an x cubed. For here, we're going to get a 6 and an x cubed. Oh, wow, this is working out nicely, isn't it? And this is going to be 12x cubed. Nice. Let's do some examples. Let's let you guys do some. Let's do y equals x squared sine x. Pause and have a go. Okay. So we're going to say u equals x squared, u prime equals 2x, v equals sine x, v prime equals cos x. You shouldn't have to really write this out in an exam, but for the sake of the video, let's do it. And it's v times u prime, so these two together, so 2x sine x plus u times v prime, x squared cos x. Nice. I'm going to give you some to do now. Let's go for number one. Number one. Y equals x cubed plus 1 e to the x. Number two, let's go y equals x cos x. Number three, y equals, let's do 2x squared minus 1 ln x. And let's go number four, let's do a big one. X plus 3, x squared plus 4. Pause and have a go. And tell me what you get. Let's do it. U equals x cubed plus 1. So I'm not going to write it out this time. The formula is v times u prime. So we're going to have e to the x, lots of, well, differentiate 3x squared plus u v prime. So just the original function. So x cubed plus 1 e to the x. And so that's your answer. You can rewrite that as 3x squared e to the x plus x cubed plus 1 e to the x. But nice. Derivative of u here is going to be 1. So v times u prime is going to be cos x. and uv prime is going to be x sine x minus x sine x. So you stay in screen minus x sine x. Here we're gonna have u v prime vu prime, so ln x lots of 4x, so 4x ln x, and then 1 over plus 1 over your original function, 2x squared minus 1. Nice. Finally, we can do u equals x plus 3. I'm gonna have to probably write this one out. U prime equals 1, v equals x squared plus 4, v prime equals 2x, and then times through like that. So you're going to have 2x lots of x plus 3, and then vu prime. So this is going to be x squared plus 4, and then let's times out. So we can get 2x squared plus 6x plus x squared plus 4, which is just going to give us 3x squared plus 6x plus 4. Nice. Nice and simple. That's your product rule. Similarly, you have the quotient rule, which is for fractions. And so let's do some examples of the quotient rule. If we have, so the formula for the quotient rule is if we have like u over v now, well, it's going to become uv prime minus vu prime all over v squared. So let's do an example. Let's go for y equals, I'm not going to do too many of these because they get kind of long and yeah, as long as you can remember the formula, you should be able to do it. Let's go minus, actually. Let's go minus 2. Probably make things a bit nicer. X minus 2. Okay. U equals x plus 1. Write it out. Let's go u prime. It's going to be 1. V equals x minus 2. I should have really done a power or something. V prime equals 1. U v prime is the formula, so plug it in here. U times v prime. Well, that's just going to be x plus 1. Minus v times u prime. Well, that's going to just be x minus 2. All over v squared. What's v? X minus 2. Square it. Bang, bang, bang. Let's simplify for the sake of it. X minus x is 1. 1 minus 2 is minus 1. So we're going to have minus 1. All over. Expand out. We're going to get x squared minus 4x plus 4. Nice. Simple. Let's do one more example. Let's go for... let's go for... y equals sine x over x. Okay. Apply your formula. U equals sine x. U prime equals cos x. V equals x. V prime equals 1. uv prime, so we're going to have sine x minus vu prime minus x cos x all over v squared, which is just going to be x squared. Bang. That's y prime. Okay. Now, just as a quick little joke, what is the integral of x sine x over x? I'll give you shouldn't need more than 10 seconds. Solve this integral. Okay, cool, let's begin. Well, we're going to take some function, f of z, e to the iz over z. So let's define this out. Let's do e to the iz over z. And now let's draw out our half plane and pick our... So we're going to go from here, and then we're going to have to go over our origin point, and we're going to come back around. And so we're traveling clockwise here, and then anti-clockwise back. So let's go big gamma. Let's go little gamma. Let's go from minus r to r. Let's call this point minus epsilon to epsilon. And so our contour integral is going to become the integral from minus r to minus epsilon of f of x plus the integral from over gamma of f of z plus the integral from epsilon to r of f of x plus the integral from over big gamma of f of z. Uh, okay, so you should be able to evaluate this nicely now. If you want to actually know what your console is going to become, you're going to have. Oh god, can I even remember it? 2i? I think it's going to be 2i, um, the integral from 0 to. Oh, I should probably specify like that. Of sine x over x minus pi I equals 0. I think it's that. And then you're going to get 2i times the integral from 0 to infinity sine x over x equals pi I, divide through by 2i. I's cancel, you're going to get pi over 2. You'll come across that soon. One day. Anyway, let's go for some more trick differentiation. Let's introduce tan, um, and just combine some of the methods we've used. Let's put up some questions for you to do, and you can do them whilst I go eat some lunch. Let's go y equals tan x. Let's go y equals 5 tan x. Let's go y equals sine x cos x. Let's go y equals tan x plus sine x. Let's go y equals sine 2x. Did we do that already? I think we did. Y equals sine squared x. And let's go y equals cos cubed x. One more. Let's do y equals cos of the square root of x. Differentiate all of these. I shall be back. Okay. So you should know this. Like, this shouldn't be something new that you're learning. But the derivative of tangent x is going to be sec squared x. Do we need to prove it? Shall we? Shall we try and prove it, guys? Like, I always love doing these proofs. It helps you understand maths better. Like, so many people say that to me about all the maths I do. That's not on the spec. That's unnecessary. You should just be focusing on what's on the spec. It doesn't matter. It's about understanding. If you don't understand maths, there's no point in doing it. It's not like economics and business where you just like memorize answers. That's economics. You memorize essays. It's not the same. You've got to understand where this stuff comes from. So let's try and do it. Let's try and do the derivative of tangent x. So should just be able to do this. I shouldn't have to look it up. There might be some looking up. But we'll see how it goes. Well, what is tangent x? It's sine of x over cos x. So let's do a little quotient rule that we just learned. Let u equals sine x. U prime equals cos x. V equals cos x. V prime equals sine x. So we should just be able to do this. U v prime, we're going to get sine squared x. Sorry, it should be the other way, shouldn't it? It should be vu prime. No, it's uv prime. Minus cos squared. That should be a minus, sorry. So we're going to have minus sine squared x plus vu prime, which is going to be cos squared x all over cos squared x. And so it really should have been the other way, right? It should have been vu prime minus the, because the cos is going to, so that's going to be 1 over cos, 1 over sine squared x, 1 over cos squared x, squared x. That's how it should have been, I think. Sine squared plus cos squared is 1. Let's just ignore the minus. Where does the minus go? Let me think about this though. It should have been uv prime, like it should have been like this. Cos squared x minus brackets minus sine squared x. Like that. The minuses make a plus. Cos squared x plus sine squared x equals 1. That's your identity. So you're going to have 1 over cos squared x, which is sec squared x. There you go. That's how you do the derivative of tangent x. Nice and simple. So Your answer here is going to be sec squared x. This one is going to be 5 sec squared x, similarly. So 5 sec squared x. This is going to be some product rule. And the answer is going to be cos squared x minus sine squared x. This is going to be sec squared x plus cos x. Sine 2x is going to be 2 cos 2x. That's your chain rule. 2 cos 2x. And this one is going to become minus. What am I on about? 2 sine x cos x. It's chain rule. This is going to become, again, chain rule, minus 3 cos squared x sine x. And then y equals cos of root x is going to be cos times x to the power, cos x to the power of half, a half. So that's going to become 2x. God, 2x cos x squared. I'm trying to do it in my head. I think no. It's just gonna be. Why is this tripping me out? Minus sine of root x over 2 root x. Ooh, that one's not nice. Minus sine of root x over 2 root x. Cool. Let's move on. Let's do some parametric differentiation. Parametric differentiation. I wrote these ones down because I can't actually think of parametric examples myself. So let's go for nice and simple. X equals t squared plus 1. And we're going to have y equals 3t cubed minus 2. And we're going to want to find dy by dx. Well, if we differentiate here, what are we differentiation with respect to for the first part? Dx by dt is what you're going to have. So dx by dt is going to be 2t plus 1. No, it's not. It's just going to be 2t. Now here you have dy by dt. And so we're going to have 9t squared. And now you have a dx by dt, you have a dy by dt. If you do the inverse of, like, now if we want dt by dx, well, that's just going to be the inverse of this, going to be 1 over 2t, like so. And now you can times through. Dy by dx times, sorry, dy by dt times dt by dx. The dt's are going to cancel, and you're going to get dy by dx. So we have dt by dx, it's 1 over 2t. We're going to be timesing that by 9t squared, and that is going to be dy by dx. So let's write it in a fractional form. We're going to get 9t squared all over 2t, and that's going to be dy by dx. And that is parametric differentiation. You can simplify that, obviously, to just 9 over 2t, like so. Trying to find some more examples on my phone here. So I did write some down because, well, it's kind of hard to do it yourself. Let's go for x equals sine t and y equals cos t. So dx by dt equals cos t, dy by dt equals minus sine t. Dt by dx is going to be 1 over cos t. Times them together, you're going to get minus sine t over cos t, which is just going to be minus tan t. Yes? Sine of cos is tan. Let me just check. I'm correct. Yes, minus tan t. Or should we do one more? One more. Three's the magic number, they say. So let's do a final one here. Do 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 do. Right, let's do one with exponentials. Let's go x equals e to the t and y equals t squared plus 1. Dx by dt is going to be e to the t equals e to the t. Dy by dt is going to be 2t. And so dt by dx is going to be 1 over e to the t. Times them together, you're going to get 2t over e to the t. Cool. Okay. Next up, the big boy. For some reason, everyone always struggles with this. Implicit differentiation. Oh, this is such a long video. We're 40 minutes in. But that's good practice. So, implicit differentiation. This is where you're going to have x's and y's. So, x squared plus y equals 25. Circle question. So, what you're going to do is x differentiates like normal, right? 2x. But when you're differentiating with respect to y, it's with respect to x, your dy by dx is going to be the derivative of the y function, 2y, times dy by dx. Because y's derivative would be dy by dx. So you're going to get 2y dy by dx. So this is going to be plus 2y dy by dx equals 0, because the derivative of 25 is 0. And so you can factor out dy by dx, put 2x plus 2y lots of dy by dx. And then you can just move the 2x over. So you're going to get minus 2x equals dy by dx lots of 2y. And so dy by dx equals minus 2x over 2y. Cancel through the 2's. You're just going to get minus x over y. Nice. And it's simple. Let's go for another one. Let's do x squared plus xy plus y squared equals 7. 2x plus, this is going to be, I always get a little bit confused. It's going to be x dy by dx plus y, or is it y dy by dx plus 1? I think it's just y dy by dx. I just got to check. In case I'm wrong. I don't want to teach the wrong thing. That'd be silly, wouldn't it? Plus, yeah, so it's going to be plus y plus x dy by dx plus 2 dy by dx. 2y dy by dx, sorry, equals 0. And now move over whatever's not there. So we're going to have minus 2x minus y equals x dy by dx plus 2y dy by dx. This is like 4 marks, by the way. Factor out dy by dx, lots of x plus 2y. Take it to the right-hand side. Minus 2x minus y all over x plus 2y equals dy by dx. Nice and simple. Let's do one more example, shall we? Let's go for... again, I'm going to have to look these up so I can actually get a good example. Let's go for x cubed plus y cubed. Yeah, let's do one where there's a right-hand side. X cubed plus y cubed equals 6xy. Pause the video, try and do it yourself, and we can then go through the answer. So this is going to become 3x squared plus 3y squared dy by dx. It's weird how I say dy by dx now instead of y prime, but that's just how I do these ones. Equals 6y plus 6x dy by dx. Move this onto the right-hand side and then take that to the left-hand side. So we're going to have 3y squared dy by dx minus 6x dy by dx equals 6y minus 3x squared. Factor out dy by dx equals 6y minus 3x squared. Divide through, and dy by dx is going to be 6y minus 3x squared all over 3y squared minus 6x. We can divide through by 3, and we're going to get 2y minus x squared all over y squared minus 2x. And that's implicit differentiation. It's nice and simple, actually. It's not too bad. It's probably my favorite method of differentiation. Let's do the final two bits of the unit. Such a long video for basics, but yeah, and then we can do some hard examples in part two. Let's go. Y equals x to the 4 minus 3x squared plus 2x. Higher order derivatives. So if I said find y prime, you could do it. We're going to get 4x cubed minus 6x plus 2. Now I say find y double prime. You're going to differentiate again. You're going to get 12x squared minus 6, and I say find y prime. This is going to be is 24x, and now if I ask you one more time, you're just going to get 24. Notice how the notation here gets a bit silly. So when we're doing higher order derivatives, we tend to just say d squared y over dx squared instead of using this formula. You can still do it. I will still use y double prime, or you can use like that. But yeah, tend to just do that. It doesn't get much more difficult than this. I don't know what else to say. If I say if I'm y double prime, wait, let me write it out properly, like how the question's supposed to look. Let's say y equals x sine x. Find y double prime. And so try that question whilst I plug my laptop in to charge. You should be getting an answer by now. Let's differentiate. Oh, God. There we go. I think it's charging. Yes, it's charging. Okay. So y prime is going to be sine of x plus x cos x. Go away. And so y double prime, differentiate this, you're going to get 2 cos x minus x sine x. Yes. Cool. We have done it. Is that everything on the unit? No, rates of change. Okay, brilliant. Rates of change. That's the final thing. Let's go. These are worded questions. So let's say the radius of a spherical balloon increases at 0.5 centimeters a second. Find the rate of increase of the volume when R is 6. So, how do you do this, guys? Well, let's do it. You're going to want to do the formula for a sphere, the volume of a sphere. I think I'm going to have to look it up and check. It's 4/3 pi r cubed, but give me a minute. Volume of a sphere. Yeah, 4/3 pi r cubed. Now you're going to want to find dv by dt. So differentiate. You're going to get 4 pi r squared dr by dt. And now substitute in r equals 6, square it, times it by a half, because you're already given dr by dt. And so you're going to get 72 pi centimeters cubed per second. Nice! I don't think we need to do another one of those. I can't be able to bother to write out another worded question. Or should we do one more? I think we're good. That is the calc basics. So we have covered now on the unit differentiation. We have done differentiating sine x and cos x, differentiating exponentials and logarithms, chain rule, product rule, quotient rule. trig functions, parametric differentiation, implicit differentiation, using second derivatives, rates of change, and mixed exercise. Oh, we didn't do mixed exercise. But we've covered the first 30 pages of the book. Should we do a mixed exercise? And then we can leave it. Then we can leave it there and move on to integration later. So let's go. Let's do some questions. Y equals 2x plus 1 to the 6. Number 1. Number 2. Let's go. Y equals x squared e to the x. 3. Y equals x cubed plus 3 over x. Number 4. Y equals sine of 4x. Number 5. Let's go for y equals ln of x squared plus 1. Number 6, let's go for y equals tan of x squared. Let's do number 7, x equals t cubed, y equals t squared plus 1. Number 8, let's go for x squared plus y squared equals 16. Number 9, find d2y by dx squared of x e to the x. And the last question, let's do xy plus x plus y equals 7. Do it. Let's give it a go. Try it yourself. Let's do these questions. So, number 1, it's going to be a chain rule. So, hopefully you remember that. 2x plus 1 to the 5 times 2. This is going to be a 12. Number 2. X squared e to the x is going to be product rule. So you're going to use your uv prime plus vu prime thingy mabobby. And you are going to get... Do I have an answer sheet for this? No, of course I don't. Oh, let me do it in my head. 2x e to the x plus x squared e to the x. Number 3, quotient rule. uv prime x cubed plus 3 times minus v u prime x lots of 3x squared. It's going to be 3x cubed. So you're going to get 4x cubed plus 3 over x squared. Number 4, I should have wrote out some answers. Y equals sine of 4x. You're going to get cos of 4x times 4. So 4 cos of 4x. Number 5, ln is going to be 1 over x times the derivative of the inside, which is going to be 2x. So you're going to get 2x over 2x squared plus 1. Number 6, what do we have? Tan of x squared, sec squared, 2x, sec squared x. Number 7, x equals t cubed. So let's do it here, actually. Let's go dx by dt equals 3t squared, and dy by dt is going to be 2t. So 1 over that, so 1 over 3t squared times 2t. Your answer is going to be 2t over 3t squared. You can cancel the t and going to get 2 over 3t, or 2/3 t, like that. So your answer is going to be 2/3 t. Number 8, x squared plus y squared equals 16. Number 8. You're going to get 2x plus y squared, 2y dy by dx. So that equals 0. So minus 2x over 2y, which is just going to be minus x over y. Number 9. The second derivative of this, well, the first derivative of this is going to be x e to the x plus e to the x. So the second derivative is going to be x e to the x plus e to the x plus e to the x. So x e to the x plus 2e to the x. Yep. And finally, xy plus y equals 7. Let's do this here. Xy plus x plus y equals 7. Um, x dy by dx. So y plus x dy by dx plus 1 plus dy by dx equals 0. So minus 1 minus y over x plus 1 dy by dx equals that. Thank you guys for watching. That is the basics of calculus, the basics of differentiation. Integration will be in the next video. And then we will do the harder questions. So we're going to do basics of differentiation, basics of integration, and we're going to do hard examples of everything. And then we're going to do differential equations, and we're going to smash our A levels. Let's get that A start. Thank you guys for watching.